All right, one of the things that synthetic division is really good for is to evaluate a function at a certain value. For instance, let's say I've got this function here and I want to know what is the value of the function when c is -3. In other words, if I plug in -3 for x, what's the value that goes with that after I do PEMDAS, okay? Now, you can do PEMDAS, and it's very time consuming and most people don't like to do that. Another thing you could do is get your calculator out and type that in and then go to the table of values, but even just typing it in would take a bit of time, right? And what if you didn't have a calculator and you had to find out what this value was? Well, there's a fast way to do it. You can do synthetic division with the number. For instance, if I want to know what the value is at c is -3, I can do synthetic division by -3. And what happens is the remainder is the value of the function at that point. So we're going to do that, and I'll kind of slowly go through that. But first of all, if you look at number 3, there's something wrong with it. They did not put it in standard form, so we need to put it in standard form before we do synthetic division. Now remember, p of x can be rewritten as y if you want to. So I'm just going to write that just because I want to just keep reinforcing that idea to you. We always need the biggest exponent first, and the cubed is the biggest exponent, so we'll write that term first. Okay, and then the next one down would be the square term, and that's the 3x squared up there. And then we got a minus 5x and a plus 2. They just wrote it backwards, didn't they? They didn't leave out any terms. We see that we have a cube, a square, an x to the first power. I'll put that exponent in. And then we have our constant, which is really x to the 0. X to the 0 is 1, and 2 times 1 is 2, so we don't write the x to the 0 down, but it really is x to the 0. All right, so here we go. We're going to find out if I were to plug in x is -3, which they call that c is -3. If I were to plug that in, what would I get? Well, I don't want to do PEMDAS because it's so, time consuming. So what I'm going to do is do synthetic division by the number they want to plug in. Now, in the earlier section, we always had to, take and use the 0, but here we're actually using the number they give us. That's the difference. We're using the number they give us because we're trying to evaluate the function at that point. Find the y that goes with that x. So we just copy down our coefficients like we did before. We got to make sure we're not missing any. We already checked that. They were all there. Remember to grab the sign, so that would be a -5 and then our 2. And when we did synthetic division, we dropped the first number down. We get a number down there, we multiply. -3 times 2 is -6. We write the result above that division line in the next column, and when we get 2 numbers in that column, we always add, right? 3 plus -6 is -3. Now, -3 times -3 is a +9. I'll write it above the line again in the next column, and when I get 2 numbers in that column, I always add. So -5 plus 9 is 4. Okay, so -3 times 4 is -12, and so I write it over in the next column and I add. 2 plus -12 is -10. Do you remember me telling you in the last video that this is the remainder? The remainder is the value of the function at that number that I divided by out front. Okay, so it is the value. That means if I were to plug in x is -3, what y would I get? I would get -10. But here they're just asking you what's the value of the function at -3, so they'll probably just write -10 in the book when you're checking your answers. Look, yeah, that's exactly what they do. But I want you to realize that's the y that goes with that x, okay? Problem number 9 asks us to use the factor theorem to determine whether the binomial is a factor of the given polynomial. What does that mean? Okay, that means, does this x plus 1 divide into that expression over there, or that equation of p of x, does it divide in evenly? If it divides in evenly, the remainder would be 0. So what we're going to do is we're going to do synthetic division, and we're going to check the remainder. That's what the remainder theorem says, okay? That if we check the remainder, if it's 0, we know it divided in evenly. If it divides in evenly, there won't be anything left over. That's why the remainder would be 0. And if it divides in evenly, that means it's a factor. So what we do with this is we use this to factor equations. If we see that something goes in evenly, we can use it to help us factor an equation and keep breaking it down, because we've got an x to the 7th here. We don't have any other ways of factoring an x to the 7th other than maybe we try taking out a GCF, and then we try looking to see if we can factor what's left, but a lot of times you can't. So this gives you a way to factor something that's of a higher degree, like this. All right, so let's try it. If I want to see if x plus 1 goes in evenly, I'm going to basically say, okay, well, what would the 0 of x plus 1 be? I'm not evaluating the function like I was in 7. I kind of am in a way, but I've got a factor. What would I divide by? Well, I would divide by whatever the 0 is. So let's set x plus 1. Let me try that again. Goodness. X plus 1. Set it equal to 0. They didn't give me a number to divide by. They gave me a factor. So I want to, if you see the x's in it, you're always going to divide by the 0, which means take the expression, set it equal to 0, and solve. If you subtract 1 from each side, we're going to get x is negative 1. If negative 1 goes into that polynomial equation evenly, then we know that it's a factor, okay? And we'll know that if the remainder is 0. I'm going to go write my coefficients down, but I want you to notice how many terms are missing here. It's like they gave us all the odd exponents. I'm going to put below it the missing terms. We've got an x to the 6 missing because we started with a 7. After the 5, there's a x to the 4th missing, so I'll put it down here, and we'll just remember that we got to fill those in. And then there's an x squared term missing. So we need to remember that. Put that 0 in. And then the constant's missing, so I have to put the constant in. I'll put it in as 0. All right, so the coefficient of the x to the 7th is a 1, but the coefficient of the x to the 6th that I added in is a 0. X to the 5th coefficient is a negative 1 because there's a minus in front of it. The x to the 4th coefficient is a 0. Remember, the coefficient's just the number out front if you're lost. Now, the coefficient of the cube term is an invisible 1, and it's positive. I don't know why I put a plus 0 in there. I don't need that plus. I've lost my place. 7, 6, 5, 4, 3. I'm to 2. The coefficient of the x squared term is 0. The coefficient of the x to the first term up here is a negative 1. It's an invisible 1, and there's a negative in front of it. And then the constant is 0. All right. When I get done, I'm going to look at this number that we get right down here. And if it's 0, I know that divided in evenly because there was no remainder. So here we go. You drop down your 1. Remember, you always drop that down first. Negative 1 times 1 is negative 1. Remember, when you get anything in the column like this, you always add. 0 plus negative 1 is negative 1. Now that I've got a new number down here, I multiply it by the negative 1 out here out front. Negative 1 times negative 1 is positive 1. Negative 1 plus 1 is 0. So we're going to multiply that 0 by that negative 1 out front. 0 times negative 1 is 0, 0, and 0 is 0. Now this can go really fast. I'm trying to slow it down a tad just to explain it to you, but you can go through this like lightning. I find this easier to do than putting something in my calculator to find a value. Okay, so we got a 0 out here. We're going to multiply it by that negative 1 out front. Negative 1 times 0 is 0. 1 plus 0 is 1. Negative 1 times 1 is negative 1. 0 plus negative 1 is negative 1. Negative 1 times negative 1 is a positive 1. Negative 1 plus 1 is 0. Negative 1 times 0 is 0, and 0 plus 0 is, I'm going to write it in orange, it is 0. My remainder is 0. What does that mean? That means this went in evenly. That means this is a factor. So x plus 1 is a factor. And so my answer to my question is yes. They asked me, is it a factor? Yes, that's your answer there. Now, what we would do with this normally is I would normally what textbooks do, and this is my first year using this one, so I don't know if it's going to happen or not. What they normally would do would give you that equation they might give you something like this to get you started. And then you'd have to figure out, where do you go from here? Can you keep factoring? Well, remember, what does all that line of numbers up there mean? It really means that that's what I've got left is a 1x to the 6th minus 1x to the 5th, and there would be plus 0x to the 4th plus 0x cubed, and then plus 1x squared minus 1x. And then we could put a 0 on the end, and then we could go try another number with synthetic division and keep factoring it that way. And there is a way to figure out what numbers to try. There's a way to get a list, and we'll talk about that at some point, I'm sure. But anyway, for this question, the answer was just yes. But this, how we would use it would be to keep breaking this thing down until we get it down into x plus 1 times x times whatever else, okay?